Hello everyone, welcome back to PISTRIS tutoring. So today we'll be looking at an example under mechanics, motions, and 1D, right? So this is part 4 of our series of videos. So let's just dive in. So we have so example 1 says a racing car starts from rest on the grid, travels along the track. Actually there should be along the track here, so let me just input that. um, Travels along the track and reaches the 400 mark after 8.6 seconds, right? So that's our question. So here in a solution we're trying to follow those steps that I mentioned in part 3, where we have a problem solving strategy, which is sketch the situation, right? We have a coordinate system, and also what show all of the given information, right? So that you can choose what so you can choose the correct equation of motion to use, right? So okay, let's get started, right? So this is our initial point. So we can just say this is our, we have x 0, we have what v is 0, we have let's say our acceleration is 0, it's a0, and then we have t 0, right? So these are coordinates here, and final we can say this is 1, or this could be initial and then the other one is final. So we have v1, we have a1, we have t1, right? So we know that we are moving to the right? We said we should choose a direction. So let's choose our direction as this. So to the right as positive, or this coordinate axis as positive. Okay. So since we have done that, now we have our sketch. It has everything that we need, right? So we can just do this. What do we know? Given it says that this starts at 0, so we can say 0 is equal to, so this is 0 meters, v0. So we start at rest, so we can say 0 meters per second, and then a will be 0, t will be 0, right? So let's just leave that out because we're starting from rest, right? We don't have an acceleration at rest. So this is our initial point, so we start there, right? Everything is there. So we'll go to x1. It says it reaches the 400 mark, so the position is 400 meters here. And then v1, what is v1? So let's see, what do they say? They say nothing about the final velocity. So is it 0, does it stop, or what? So let's just indicate it as unknown, and then let's look at time. So t1 is equal to 8.6 seconds, right? And we know that t0 is equal to 0 seconds. But what is a1? We do not know, right? So okay, so this is our information, right? We are given the position or given the time. So let's get to that. What are our questions, right? So let's say A, they want us to calculate that. Let me just check the questions. It says we should calculate the average acceleration, right? So average acceleration, um, acceleration. So I said for the scope of this tutorials, right, we'll only be looking at x is equal to change in vx over change in t. This is what gives you our average acceleration. If we're looking at what at change at dvx over dt, this will give us instantaneous, right? So this is at it changes at every point, right? But this one is just an average of 400 meters, but this one will be for each and every point, right? So that's the difference when you talk about average and instantaneous values. So we have this, What's our change in velocity? What's our change in t? We know our change in t, we do not know our change in velocity, right? So we can get the velocity by using one of our laws of motion, right? So let's see which one can we use, right? Oh, we can also get the acceleration by just using what? You can get the acceleration straight away by using this, right? We have initial velocity, we have the final displacement and time. So let's check which one we can use. Let's see. Okay, we have one here that I've found that we can use. It has a xf and xi, so it's this one. So we can use this one. Xf is equal to xi plus vi change in t. So this will be our 1 and 0. So let's just write it in that format, like the one we're using for this question, right? So let's just do this. So for this, you don't need to worry about memorizing them. They will always be given in your formula sheet, right? So you can just take the formula sheet and then you'll find all of this if you need them. So we have our AX, right? This is our average, and then we have the change in T. We know this is 400. The one at x0 is just 0. This is 0, so this will multiply 0.6. Necessarily have to multiply because that will be 0, but let's just do it. 1f over 2 by what? By ax by 8.6 to the power 2, right? So let's see what we get. Let me just punch and see what half of 8.6 squared gives us. Right? So half of let me just rearrange this very well. So so let's just see what 400. So we know this gives us 0. So we can just go ahead and write 36.98 AX, right? This is when we calculate this 1 over 2, right? So let's divide by 36 over 36.98. Therefore, AX, which is your average acceleration, is 400 divided by 36.98. You get an average acceleration of 10.82 meters per second squared. You can write it like this, or you can write it meters per second squared, right? These two is okay, right? So this is what you get when you calculate your average acceleration. So now we have an average acceleration, right? So this will be our constant acceleration. Actually, let's not assume that. Yes, it will be a constant acceleration because we have used what is this? We used an equation of motion, right? So let's go to B. Um, so B wants us to calculate the final velocity, right? What is the final velocity? So let's do that. Final velocity, which is v1, right? So we can just use the formula for average acceleration. So this will be a vx over change in t. This is equal to v1 minus v0 over change in t, right? We can rearrange this one, and when we rearrange that one, will give us v1 is equal to so I'm gonna write this nicely, is equal to v0 plus ax change in t, which is our equation of motion, right? And then you want this v1, so this will be v1 is equal to, when this is 0 multiplied by 10.82 multiplied by 86, right? 8.6. Therefore v1 is equal to, that's your final velocity, put it to pi 8.6. So we get 93.052, right? 93.05 meters per second, right? I like to write it like this. So that's our final velocity. Right, let's fix this so it's much better. Yes, 93.05. So we calculated our final velocity. So let's say it. If the car slowed down at a is equal to 2 meters per second squared, right? Calculate the time it takes for the car. Calculate the time it takes for the car. Takes for the car to stop, right? So we need to calculate the time it takes for the car to stop, right? So now our vehicle is slowing down at so let's just go back to what we had, right? Okay, this is our diagram, right? It's always better to come back to your diagram. So when we pass this mark here, right, our vehicle was moving at what? I was moving at 1, which was what was its final velocity? 93. Yes, it's moving at 93, which is very high. That's what you expect actually for racing cars, right? At 93.05 meters per second, right? And the acceleration, which from what? From here up to here was what? Was 10.82 meters per second squared. But when the car reaches this point here, it starts slowing down. So this velocity will decrease until it reaches what? v2, which is equal to 0 meters per second, right? And the acceleration at which this happens is what? Is 2 meters per second squared. So after how many time, after how many seconds will this happen where v2 is equal to 0? That's what we want to understand, right? So let me just erase this. This is just an explanation, right? So we'll write this proper. But that's what I wanted to explain so that there's no confusion as to why we have a different acceleration. The average acceleration is from 0 to 1, and then from 1 an acceleration changes. The acceleration changes to 2 now, and it's negative, right? So I forgot about this. I didn't put directions, right? So it's very important. It's 10.8 to the right, because we need direction in your scalar. So this will be to the right? Yes, it's to the right. So these are positive, this one. So let's just write our data. So we are given what? V1 is 9.05 meters per second, which is positive. So at V2 we want to have a 0 meters per second because we want the car to stop. What is the change in time? We do not know. What is the acceleration? It's minus 2 meters per second. Why is it minus? It's slowing the car down, so it has to be in the opposite direction, which is to the left. So it will be a negative, right? So which equation can we find to find this change in t? Well, we have all of these. I know an equation that I like that. We have used it before now. So it will be this one, where final velocity is equal to initial velocity plus ax multiplied by change in time. This will be a 0. this will be your 93.05, and this will be your plus into minus 2 multiplied by change in t. So we are going to have, so if this is negative, we take it to that side, it will be positive. So you're going to have 2 change in t is equal to 93.05. Therefore, change in t, this will be divided by 2, right? Divided by 2, you get, let's see, 3.05 divided by 2, that's 46.525, right? 525, you can write it as 5 or as 0.52 because we have 5 and we have 0 after that 5. So you can just write it as 52 or 53, it's fine. So 53, so that this depends on, you can just say, okay, it's 5, so I can round up, right? Or you can say, it's 5 and there's 0 after that, so you can just use two significant figures. You just bring that down to what to two numbers after the decimal and just have it as 2. It doesn't change that much. But 5.3 is 53 is fine. If you're not sure, just write 5 point, just write 525, right? So this will be your time it takes to stop, right? It's not even a minute, so you have to respect the acceleration of a racing car. That's pretty much high, but for that velocity, it makes sense, right? So let's see, we're done with that question. So let me just give you a brief run on what did we do. So we had our racing car, right? We had our question there. So we just drew the diagram, and after drawing the diagram, what did we do? We looked at what was given and what we didn't have, right? So we have what we have this as what our 0 position original, we have 1 here, right? And then we calculated the average velocity. We just picked an equation of motion that had what we wanted and what we needed, right? We found what we needed by substituting what we wanted. The answer had a value and the direction. Next thing, the same thing with B. We found the equation, right? Correct equation. We found the answer with the direction. For C, we found it was just time. So time has no direction, it's just the value. And we had the negative -2 as our acceleration because the car was slowing down. So that's how you do you answer questions for motion and 1D when you're given them, right? We just follow what we said we follow. Let me just scroll back. It's draw a diagram, indicate given information at all stages, choose a positive direction, choose the correct equation, indicate what is required information, units and direction, and answer. We did all of that, right? So our answers are correct, right? Thumbs up. So yeah, uh, on the next video we'll look at another example. This one is a free fall motion, right? Because this was on a ground level. So we want to look at equation at the an equation when you are in a free fall, right? Not on the ground but rather in the air. Okay, so until next time.